Hello and welcome to your basic debugging lecture. So what we're going to talk about today is probably things that you've already covered if you took 230, but a little refresher can't hurt. So we're basically going to talk about when your code isn't working or when you get errors that you can understand, what do you practically do? We're not going to talk about anything complicated like using an actual debugger program or anything official like that. Literally just practically, what do we do in this class when we have errors in Python that we can't figure out? The first thing that I want to talk about, again, should probably be a little bit familiar to you. And this is when you get an error, look to see where Python says that the error is coming from. Python error messages are actually really great in terms of error messages because they usually give you at least a little bit of an idea of where the problem is coming from and maybe what caused it. So whenever you get an error, be sure to look and see, okay, what line is causing the error, and see if there's something obvious that you can pick out that might be the problem. Common things that people miss are forgetting to close your parentheses or forgetting a square bracket or a colon, maybe indenting when you shouldn't or not indenting when you should. Maybe you also misspelled the name of a variable or a function or a keyword. All of these are things that are super easy to miss when we're writing code, but hopefully when Python tells you where the problem is, you can focus in a little bit and try and see if one of these common issues is what's going on with your code. Let's look at an example. Okay, so first I'm going to open my notebook, and as an aside, this is a really common issue that I see when we're working with Jupyter notebooks rather than running entire scripts in Atom like you might be used to. And that's when you're running a notebook, you need to make sure you're running the cell that has all of your import statements. So I'm going to go ahead and do that first because I want to make sure that I don't get that error. Okay, now that we're loaded, let's look at our first example. So I'm going to run this code, and it's pretty simple code, so to speak. You're just doing a little bit of math here. I'm doing a bunch of math, assigning it to a variable. Let's go ahead and run. Oh no, I got an error. How unexpected. So when we see the error, that it's a syntax error, and Python will actually tell us exactly where it thinks that the problem is. Now notice here that it thinks that the problem is with the line j equals 2 plus 2. But I'm looking at that line and I am looking at the syntax and it looks beautiful to me. So one thing to realize is Python will tell you where it thinks the error is, but it's not always the case that the error is exactly there. In this case, if you have sharp eyes, you'll see that the error is that I'm missing a parentheses on the line above. Now, Python thinks that the error is on the next line because since it doesn't see a close of the parentheses, it moves on and tries to process the next line as part of those parentheses and gets very confused when it sees variable equals in there and it throws an error. So if you ever have an error and you don't see anything wrong with the line that it says the error is on, make sure you're checking a line or two above and seeing if you forgot one of those things I mentioned. Closed parentheses is probably the most common. In fact, if you've been in my 230 class, you might have seen something I do that's really silly is I can usually tell on first glance if someone's code is missing a parentheses, if that's the only problem. And so something really silly I do is I'll cover my eyes and I'll tell them, like, I bet I can tell you what's wrong with your code without even looking. And I tell them it's a missing parentheses and I am usually correct and they are very impressed. So now you know my secret, but it is a really good thing to check out if you get an error that you don't understand on a line that looks perfectly fine. Okay, so obviously the first thing to do is to see if there's anything obvious that you directly can see and fix, but that's usually not going to be the case. So if you don't understand where the error is or what the error actually is, your best bet is to Google the error message. And I know that that seems super obvious, but it is usually the best thing to do. And luckily in Python, when you get an error message, you can just highlight everything in the error message, copy it, and put it straight into Google. I highly recommend looking on the site Stack Overflow because it's kind of a one-stop shop for all types of problems that you can have with coding in any language, but definitely in Python. So if you ever have an error that you don't understand, copy and paste it into Google. Check first if there's something on Stack Overflow, because that's usually the most useful. But even if there's other websites that can help you, at least they have some information that you don't have. Let's look at an example of this. Okay, so I'm going to run this cell of code, and basically what I'm doing is I'm taking a range of integers from -5 to 5, and I am calculating the inverse, and the inverse is just 1 divided by that number. So my for loop here says for each number in my sequence, print 1 divided by I, the number. So let's go ahead and run this. Oh no, we got another error. Okay, so when we see this error, we might go and say, okay, what line is it on? Print 1 over I. Well, okay, I'm not missing a colon. I'm not having some weird indenting problem. The line itself looks fine. I'm just printing the result of a division. So I'm really confused. I don't understand the error. I'm going to take my error message. Now, don't copy your code, just copy the error message, copy and paste, and see what Google has to say. And typically when you're Googling these errors, something from Stack Overflow should come up, but if it doesn't, just scan for it a little bit. It's usually really helpful. And I'm going to click on this. Now, this in Stack Overflow is going to tell me what the problem is that people had. And then if you scroll down, you'll get people's responses to maybe some solutions to that. So from reading this, I can see that I have a 0 division error, which essentially is saying you can't divide by 0, but you were trying to do that anyway. So I go, oh, okay, that makes so much sense. If I'm doing every integer between -5 and 5, then 0 is going to be in there. And when I divide 1 by 0, of course I'm going to get a 0 division error. So now that I know what the problem is with the help of Stack Overflow, I can try and fix it. So one way, although there's many ways to fix this, I could say if I not equal to 0, and then indent this. When I run this, now I get perfectly running code, and I'm no longer getting my 0 division error. Okay, so if you can't see anything directly wrong, and maybe Stack Overflow and Google haven't been super helpful, one other thing you can try is to use print statements. Print statements are incredibly useful to check whether certain blocks of your code are running or what objects look like that you're using. And print statements are just kind of like a poor man's debugger because you're able to see what objects are or see when code is running. So for instance, let's say that you have an if suite and it's not running, or at least it's not running according to what you can see in your output. Well, if you want to check if you actually are running that if suite, what better way than to just add a print statement at the beginning of that suite and see if it prints out in the output of your code. Or let's say you have an error when you're working with some data and the program is telling you that the data should be only 0s and 1s, like a binary variable, but it has other numbers. Well, you expected it to be a binary variable, but let's print it out to see if it actually is. Print statements are really useful to look at your data, to look at your objects, your lists, your dictionaries, to see if they actually contain the things that you think they do, and make sure that everything looks good. Let's look at an example. What we're going to do here is we're going to look at some data. And this is something that we're going to do a lot in this class, so don't worry if the syntax of the pandas or Python syntax is a little bit confusing to you, because this is something we'll do all the time. But what I'm going to do is I'm going to read in some data. You can think of it like an Excel spreadsheet or a Google Sheets spreadsheet. I'm going to print the data, and then I'm going to look at a certain column. So when I run this, oh no, I get an error. So when I printed out my data, you can see that right here before I got there. You can see this is essentially a spreadsheet, and I have an age column, an ID column, and a number of cats column. Maybe I'm trying to do some cat lady related analysis. Well, I wanted to look at just the age column, but I got an error. But everything looks fine to me. So I'm kind of confused as to why I got this error. And just as a note, when you're using other packages like pandas or NumPy or anything that we're using, sometimes the error messages can look a little more complicated than what we were looking at before, because there's a lot of stuff in here that is not code you wrote. And so what you want to do when you get an error like this is to look for the line of code that you recognize that is in your code and not in the actual package. So for instance, I'm going to look through here. Okay, all of this is not code that I wrote. Okay, but this is. So I can see that the cat's age is where I got my error. And it says key error, which basically means that it doesn't think the column age exists in my data frame. But I literally just saw it when we printed it out. So let's use a print statement to see what the actual names of my columns are to make sure I don't have some kind of silly error. Okay, and we'll comment this out to make sure it doesn't give us another error. Okay, so now we're running our code again and we're printing out our data frame again and all of the names of the columns. And oh, okay, I see what the problem is. Now that I've printed out the names of the columns, I can see that there's a random space before the column name in age. So that's probably what was giving me an error, because Python thinks the name is not age, but is space age. So I could go in and fix this, and we'll learn how to do that later. But for now, what I'm going to do is I'm just going to say cats space age to get the column of ages that I want. Let's run this and see if it works. And it does. Perfect. So now I've grabbed just the column of all of the ages, and if I wanted to do something with that, plot it, take the mean, whatever, now I can. Okay, let's talk about some common issues that you might come across when programming. I'm sure you've come across a lot of these before, but I just wanted to give you an overview of things that might come up, especially as it pertains to the kind of programming that we're going to do in this class. So as I mentioned before, first thing to look for is syntax errors. Did you miss a parentheses, a colon, a closed bracket? Did you indent when you shouldn't have? And sort of relatedly, did you misspell anything? When we're doing data science, our variable names can get a little crazy long because we're usually describing something in the data. For instance, if your variable name is children's age standardized, that's pretty long. It's a lot of opportunity for misspelling something. So make sure when you see weird errors that you don't understand and your code looks okay, make sure you don't have one of those silly syntax errors in your code somewhere. Secondly, as I also mentioned, make sure you're importing the correct packages. If you're using something from NumPy, make sure you've imported NumPy. And as I mentioned before, when we're working in the Jupyter Notebooks format, it's a little bit easy to sometimes skip over cells, so make sure that you're running your import cell if you're importing any packages. Again, as I mentioned before, make sure your data and your lists and your dictionaries and etc. all look the way that you think they do. Printing them out is a really good way to do this and make sure that, for instance, if you have a data frame that you think only has column names with no spaces in it, print them out and make sure that's the case, like the example that we just saw. Often when we're working with data that's not something that we created, which is going to be almost always, there might be some surprises or things might not look the way that we assume they will. Maybe there's missing values, maybe there's unexpected values, and printing out these objects is a really good way to see what they look like and see if that's what's causing any errors. Now, this next one is a little bit less common, but it definitely still happens. And this is basically what happens when you create a function, which we'll be doing a lot of, or you use a function that doesn't return anything. So if you're like setting a variable equal to the output of a function, but you didn't return anything, you're going to get something called none. So if you ever see like a none type error or the word none somehow coming out in your output when you didn't expect it, make sure that your functions that you want to return a value actually do return a value. And lastly, this is very data specific, but check if there's any missing values in your data. Sometimes things don't look the way that you think it will, and missing values is a really common way of that happening. When we have real world data, we usually don't have complete data where every single row has every single value for every single column. Checking if you have missing values or printing out your data frame to check yourself if there are missing values is a really important way to address errors in your code, because sometimes the algorithms or functions that you're using won't accept missing data, but there actually will be some in your data frame. Okay, so last but not least, if you've tried all of these things and you still don't understand what's happening and you're still having trouble, you can of course come to me with help. But I highly recommend making sure that you try all of those things first and see if you can fix the error on your own. Not just because I don't want to have to keep you waiting, but also just because it's empowering to be able to fix your own code and errors when you have them. So if you ever need to ask me for help with a coding problem, make sure you send me all of these things. First, I need a screenshot of your code. Now, sometimes I'll ask you to actually send me the file or copy and paste it into Slack or something, but for first round of just trying to see what's wrong, a screenshot of the code where the problem is, where the error is, and a couple lines above and below is very useful. Similarly, if there's an error, make sure you send me a screenshot of what the error actually says. Third, make sure you tell me what you've tried and looked up that did or did not work for you. For instance, you could say, here, look, I looked at this Stack Overflow, but doing this didn't help, or, well, I Googled this error, but this didn't help. Whatever you found, make sure you tell me so that I'm not making you try things that you already have tried and just wasting your time. And last, just give me a quick summary of what you've tried to do to fix it. And make sure that you're trying to fix things before you're reaching out to me, just because I don't want you waiting on a Slack or email from me when you could be working on a project or homework or something. So make sure you try a couple things and tell me what those things are. Okay, hopefully that wasn't too overwhelming. Just wanted to do a little review of how we handle errors and what debugging is in Python. I will see you next time.